Well, let's try this process again of finding the derivative of a logarithmic function by using our properties of logarithms in order to separate and rewrite our logarithm expression in a way that's a little bit more friendly towards taking our derivative. In this case, we might note that y equals the natural log of the cube root of the quantity x plus 1 over x minus 1, which I'm going to rewrite as y equals the natural logarithm of the quantity x plus 1 over x minus 1 raised to the 1/3 power. Well, rewriting this, we can use our exponent property here, which would say that y would equal 1/3 of the natural logarithm of the fraction x plus 1 over x minus 1. And then we can separate this using our quotient rule again, which states that this expression will be the same thing as 1/3 times the natural logarithm of the quantity x plus 1 minus 1/3, I'm distributing that 1/3 to both terms here, the natural logarithm of x minus 1. All right, now this is about as simplified as we can get, taking this logarithm and spreading it out as a sum or difference of logarithms with no exponents. And that's a useful thing to us because now we can take advantage of our rule here once again that says if we take the derivative with respect to x of the natural log of some quantity u, it will be the same thing as the derivative of the quantity u divided by u itself. So going back to our derivative, if we're interested in finding dy dx here, well, our constant multiple rule says that our derivative will be 1/3 times the derivative of the natural log of x plus 1, which is to say the derivative of x plus 1, which is just 1, divided by the argument x plus 1 itself. And we would subtract from that 1/3 times, and in this case we take the derivative of the argument x minus 1, that derivative is 1, divided by x minus 1 itself. Now, this is two fractions with lots of other things going on right here, but we can simplify this one pretty quickly using a little bit of algebra. Dy dx in this case will equal, if we get a common denominator, actually, you know what I'm going to do? I'm going to factor out my 1/3 first. Let me just leave that separate. And I wanted to subtract 1 over x plus 1 minus 1 over x minus 1. I would get my common denominator of x minus 1 times x plus 1. So we're going to get 1/3 times the quantity, let's see, x minus 1 times 1 in the numerator minus 1 times x plus 1 divided by x minus 1 times x plus 1, or x plus 1 times x minus 1 if you're looking at this particular order here. And simplifying one more time, we know that x minus 1 minus x minus 1, that's going to just become -2 in the numerator. And in the denominator, I'm going to have 3 from my fraction in front right here times the product of x plus 1 and x minus 1. That's like saying x squared minus 1. And so in completely simplified form, here's our derivative. And I would say it's a lot less work than having to try to find the derivative of the cube root of x plus 1 over x minus 1 all by itself. Taking advantage of those logarithm rules is a great way to go.